From product innovation to manufacturing, from incoming goods testing via process monitoring to final product quality control, the various positions in industrial value chains require a detailed understanding in real time of raw materials, intermediates, and final formulations.
So the technology of nuclear magnetic resonance brings several advantages over other orthogonal analytical techniques. This is, so to say, it's very untargeted. So we can capture any kind of substance and material within single runs of analytics. And also it doesn't require any compound-specific reference material for quantification. So these are general advantages of the technology, but applying it then to industrial value chains, the value chains are covered from an end-to-end perspective. So there are designed applications for R&D and product innovation with very sophisticated high-resolution instrumentation, but also derivatives out of it brought to benchtop instruments, smaller derivatives out of it covering manufacturing environments. So this brings advantages in harmonized methods because designed products and the analytical technique with it can be rolled out into production for incoming goods control, for process control, and final product quality control.
A significantly more innovative and efficient way to address modern testing landscapes in industrial process monitoring is to apply different expressions of the same technology. Analytical solutions are individually tailored to meet the requirements of the various stakeholders involved in bringing an innovation to market and maintaining performance throughout the product lifecycle.
As our customers supply since decades floor-standing high-resolution NMR in the R&D centers, in the product innovation step, rolling it out then, the new product, the new formulation of our customer into manufacturing environments requires a sort of harmonized methods. If you apply a totally different technique in incoming goods control, process control, or final product quality control, you would even have to adopt your analytics onto a new product innovation. If you stay within NMR and just use a derivative like a benchtop FT NMR system like the Fourier 80, the transfer of the development, the deep understanding the customer has at the product innovation step, transferring this into incoming goods control and final product quality control by using the same technique. This very much speeds up the process. And one has to mention, in the manufacturing environment, end-to-end solutions are the key point. So software-assisted data interpretation. And this is rolled out on benchtop systems. But if there occurs a problem in failure analytics, for example, if the quality control fails at the end, interpreting the issue and readjusting the process in production is easier because the R&D scientists already understand the technique of the analytics. So they can interpret the data quicker and they can conclude their outcome of this failure quicker and correct it in the process. So having these harmonized methods over the whole value chain in industry helps speeding up the process, getting quicker to market with a new product, with a new innovation. So this is time to money for the customer. But also, if in the quality controlled environment, one technique is used and the very same one, like our fully automated benchtop systems, in the next stakeholder for the incoming goods control, this result comparability is given. So everybody is talking the same thing when we compare specifications and batch-to-batch consistency of products, for example.